Now that you've seen so many other buildings with similar forms, twisting shapes arise in the past 10 years, what's your reaction? And do you wish you'd done anything differently with the turning torso 10 years ago?
No, I think certainly in many aspects, turning torso was rather a pioneer building. Nevertheless, also because it is so slender, isn't it? Although it's not by far not the tallest building, but the slenderness, I mean the relation of the ratio from the width of the bases to the height is enormous high. And so it was also an interesting technical achievement for the time. And I think has also motivated and encouraged many people also to go for apartment buildings, rather in a slender form than the usual way we has been accustomed to seeing, which there was more larger compounds.
Do you wish it had had a different height?
No, I think proportionally is well. There are 9 cubes over each other. It's almost like you see, it's a little bit like a canonic way you see when you accustomed to draw, many years ago, when I was at the art school, you see the Greek models, they are so many heads. You see the measure of the head is also the measure of the body. It can be between maybe 8 heads, to 9 heads. You see, it gives you a complete body, isn't it? And since the turning torso merged from the idea of the human body, I thought it was a good proportion, a good ratio.
In your own work, is that something you've taken from that project and applied elsewhere, that proportionality? Or what lessons does that project have for you that you've applied and developed over the years since then?
Well, certainly you see the Chicago Spire was, in my opinion, even more slender, even more daring as it should be, even taller, also 2,000 feet high, isn't it? And also, however, preserving an equation by itself, of proportions, measures, you see harmonic measures, you see all in dimension in golden section, and also with a golden number in the basis, 7 supports, around the core, and working with patterns very close to those that the turning torso had generated before. However, you see, as an autonomous building, as a building by itself, finally very different, you see, from the turning torso, but you see the essence of the building was very, very close to, I mean, in other words, the step of the Chicago Spire, for me, will be never possible without having done before the turning torso, which it is a logic way, one, like a painter, one painting brings the other and so on. It's a succession of, one painting gives the solution to the previous one, and it's the problem for the next one.
Do you think the Chicago Spire will go forward at this point? I gather you would still be interested in working on the Spire if it does come back, but...
Well, I mean, we went very far with the Spire. I think the foundations are already in place, isn't it? And even part of the excavation, and also the Du Sable Park, has been projected, and a lot of the connection you see even to the highway has been also done. So a lot of work has been done, isn't it? Almost is magic. I mean, and it was such a beautiful project for this so beautiful city. I mean, I didn't came to Chicago in a while, and yesterday I came here, met my wife. She was in New York. We met here. And it was really a joy to be here, and again, to see how beautiful this city is. Even this morning, coming here and getting along the Michigan Avenue, and seeing the beautiful buildings, I mean, it's quite a place, to do a great building, Chicago.
Back to the turning torso, another way that it was pioneering was incorporating a biogas system where waste from the building contributes to energy generation. Was that difficult to get off the ground back then? And have you become more interested in such waste-to-energy projects or on-site energy generation in your building since then?
Well, you see, we have been always very conscious, about the impact, the environmental impact of our building. Working in Sweden, Swedish are almost pioneer, in this type of approach, you see, to do. And my client, HSB, is also, as I say, 90 years, those days, of experience, working in development, and they has been always doing modelic settlement, you see, modelic in a way. And just to tell you, when we was working here in the Chicago Spire, we was using water of the Chicago River. We got permit, you see, to have, to use the water for cooling and heating, of all our building, which it was a pioneer gesture, and this, studied with a lot of care in order to don't disturb the biological equilibrium of the whole shore or the river in this part of the city. So, I mean, it has been always our preoccupation, you see, of achieve buildings that are, I mean, not only architecturally correct, but also environmentally, very adequate.
The steel structure that wraps the turning torso, was that the only option considered for how to reinforce that building? How did you take the sculptural form that it started with and realize it as a building? What sort of structural ideas were considered?
Well, you see, when I have to say today two things, in my opinion, are crucial. It's true that I am a sculptor, and it is true it was my first vocation, to paint and to sculpt. Going to Paris and seeing Notre Dame, I decided to become an architect because I thought that's a wonderful thing that no painter or no sculptor will be able to do. And so I was intrigued, from the world of the architecture. Studying architecture, I decided to become an engineer. And I make the full studies of engineer, although so in Zurich at the Polytechnic. Even I have done after that work during 3 years, a PhD on mechanics, you see. So I went more and more into the technical world, but always I was sculpting and working and drawing. So when I started, you see, after my studies, doing that even more with more time and more dedication, I think the first creatures who came out of it, and they are very much related to my engineering background. Because this was the last serious thing I was doing before I started doing them. So they, in itself, if you look these sculptures with cubes, they are enormous, minimal, call it like that, you see. They are also enormous cerebral, as architecture is, you see. Very little intuitive, the intuition is very much set in background, very little expressive, and very much, as I say, cerebral, you see. All these things, makes that you can easily transform them into an engineering or an architectural fact, because they embodied in their own nature, probably the essence of them is also very much engineer-wise. Now, of course, you see, when you started dealing, with the problem of making a building like the turning torso, I mean, it's not a joke, it's a tall building. You see, it's a very tall building, it's exposed to the winds, exposed to problems of turbulences, you see, of vortex shading, shading of the building, accelerations, and all of that, comfort of the people living there. And then you are confronted with the real reality of finding artiluge, you see, to control of all of that and deliver a structure who is, first of all, feasible and even economically feasible. Like, for example, the repetitivity, the sliding core, the structures, the elements in the spine by itself, who are rather repetitive and all of that. And you try to allocate, you see, some, concepts who has to do with the real problematic you are living into the nature of those structures, a structural element. Like, for example, I described the fact that, you see, if the building mates maybe have deflections, and that's not a problem. The problem is the speed or the acceleration. You see that because it's this who makes you feel that the building is moving. So in housing or living up, the restrictions are very high, double as high than in offices, for example, where the people move much more. But in your house, you may maybe see it, read a book or watch television or whatever, or even you see, and then you have to feel well, isn't it? So this restriction was possible to accomplish without having to add a mass damper into the building through the interference or the common work of the spine with the core. The core much more rigid with a much higher frequency, you see, and the spine itself very elastic, you see, with a much lower frequency, own frequency. So both together, they in a way or another complement and makes a comfortable building. I mean, it's just to give you an example, but what it is important is to understand that no thing there, you see, as it happens, as it should happen also in architecture, you see, is just done by case. Everything you see, as I say, in my opinion, architecture is a very cerebral discipline, isn't it? It's also a very cerebral art. You see, it's something, you know, who goes, even the fact that you have to draw almost everything and give it to do to other people. The fact that you have to put to everything a dimension, you see, to say this is an inch, this is an eighth of an inch, this is a tenth of an inch, whatever, you see, and you counts, the small dimension counts even, you see, in the product. So everything has to be thought, everything has to be fixed, everything has to be dimensioned. Very little space, you see, for at the other side, you see, your question is so interesting, you know, because you see, there are so many casualties, you know, in architecture. For example, the clouds who are moving, the blue of the sky, the light, the shine of the sun, you know, the midnight sun, you know, the white nights, you know, in this part of the world, you know, is very much northern, you know, so they get in the month of June, they get almost day and night, they are touching each other, you see, almost in terms of that there is almost no night, you see, there is just crepuscular light, very horizontal, all those things, you see, the shadows, you see, all of that, you know, the reflects, the water, the colors of the water, the green around and all of that. This is all adding life, isn't it, to this very rational fact of approaching to a project who has to be realized and has to be defined until, as I say, the tenth of an inch and even less.
Yeah, I want to ask you one more question about that. It's interesting that you say this about sculpture and painting, and I wonder if you consider your buildings sculptures and how you draw the lines between sculptural forms and architectural structures that arise to meet demands.
You see, certainly architecture is not a sculpture, certainly, for sure, because mostly the arts are complementary. You see what I mean? The arts are complementary. So, I mean, sculpture and painting are two different things. And sculpture, painting, and theater are also three different things. And all of them are art, or literature, you see, wonderful poem, you see, movers, you know, touchers, you know, but it's a complementary thing. So architecture is also complementary to the rest of the arts. However, you see, it nourishes itself from all of them. You see, I mean, that, for example, one of the most beautiful moments of expression on architecture is, in my opinion, written by Victor Hugo, you know, the French writer, in the Notre-Dame de Paris, in the chapter Ceci tuera cela. It's one of the most beautiful apologies on the architecture I never read in my life.
What does it say?
Just not to tell you also, for example, you know, the most beautiful support to painting, you know, is the architecture of the Sistine Chapel in Rome, where Michelangelo has done this wonderful work. And if you take away the figures, you will see there is a whole coulisse, a whole scenography done in architecture. You see the arcs, he painted the arcs, he painted capitals and all of that. So almost 40–50% of the painting is architecture that he recreate in the vault of the architecture of the Sistine Chapel. So again, you know, another example. And you see, if you look La Galerie de Roi and the portals of Notre-Dame de Paris, you have one of the most beautiful collections of sculpture of the Middle Ages in the world. And it is intrinsically part of the architecture of Notre Dame. So what I want to say with that, it is that architecture is the most abstract of all the arts. Is the most abstract. And it is even done with all kinds of materials, with stone, with concrete, with steel, with glass, with wood, with fabric, with whatever. You understand? Even with branches of trees and things like that. You can do architecture with mog. You can do, you know, the huge are built with mog, isn't it? Or even, you see, I mean, it's just to tell you that, you see, so, and as material as it is, I arrived to the conviction that it is almost like an aura or a skin, you understand, who virtually involves, the buildings themselves. And even it is not the building itself, but this aura, this skin, you see, who makes the building, touch us and move us.
That's very interesting. Thank you very much for your time.
Thank you.